In this video, we're going to look at an issue with using the registers whenever we are jumping into subroutines or nested subroutines. Now, this is a point that was made by Timothy Morgan, who has helped me out quite a bit with a lot of my coding. So the point that he makes here is that if we were to look at the example of the power function, which I showed you on the last video, then in this instance, the power function here, we're going to use the index register, register R0 and register R1. So we're writing over these registers. Now the question is, what if there was values already in those registers that we want to maintain? And here we are calling the function from a routine, and that routine might require the values that are in those registers, and we're going to write over them within the subroutine. So here's a small example here, and again thanks to Timothy for actually producing the example. If we were to put a value into register R2 here at this level, but we come down into the subroutine here, and you'll note that we're copying register R0 onto R2. So whatever was in register R2 is going to be overwritten. So if we come down further down the code, once we've worked through the subroutine and come back out, we're going to make a comparison with register R5, which is the result of this subroutine call, and also register R2. Then we're not going to get the correct value because we've already written over the register R2. It no longer contains 25. It contains the value which was in register R0. So we need some way of ensuring that whenever we get into subroutines, that we save the values of the registers that we're going to write to within the subroutines. Otherwise that information gets lost. So there are several different ways for us to do this, and that's what we're going to look at in this video. And it's best to get this sorted now before we start introducing any more subroutines. Now, it was different whenever we generated the subroutine for the absolute value, because the subroutine for the absolute value never used any of the registers. It used dedicated memory locations, which I have set aside. So those dedicated memory locations are never going to get written over because they're dedicated to the actual variables that we're going to use within the subroutine. But the registers can get written over, so we have to be careful that we take note of the original values and then reinstate the original values after we have worked through our subroutine. And this is especially important as well whenever we have nested subroutines. So we call one subroutine and it calls another subroutine, which calls potentially another subroutine. We need to be careful to make sure that we maintain the integrity of the values for the registers in each of the subroutines further up the hierarchy. So let's do that now. So as I said, we have a few options. So let's look at the first option here. Now this is the calling function for our power subroutine. So what we can do is, before we actually call any subroutine, we push all of the values from all of the registers onto the stack. So we've got a copy of them. And then we can go in and we can push our variables onto the stack and then jump to our subroutine. We work through our subroutine and all of the registers are available to us within the subroutine. We don't need to bother about overwriting them because we have a copy of them in the stack. And then once we return from the subroutine, we pop all of the values off of the stack back into the registers. But rather than writing that out every time, we could have two separate subroutines. So we could write a subroutine that pushes all of the values from the registers onto the stack, and we could write a subroutine that pops all of the values off of the stack back into the registers. So this is a bit of a nuclear option because we will be doing a lot of unnecessary work. So let's say, for instance, the subroutine only uses one register, R0, then we will be needlessly pushing the values for all of the other registers onto the stack. So it's basically a bit of wasted CPU time. And of course, if you multiply that up by every subroutine and every nested subroutine, it's quickly going to take up 1, a lot of space on the stack, and 2, a lot of time. So although it will work and it's simpler for us to do, it's not really ideal. So let's look at another option. Now the second example here is similar to the first one. Instead of pushing all of the register values onto the stack and then popping them all back off, what we can do is we can just push on the register values that are actually used within the subroutine. So for example, the power subroutine uses the registers R0, R1, R2 and the index register. So we can just push those onto the stack, and then we can work through the code as normal, and whenever we return from the subroutine, we can just pop the values back off. So that has the added advantage that we are not unnecessarily pushing and popping values that we don't need to. So it's going to save a little bit of processor time. But the problem or issue that I have with this one is that it means that whenever you write your assembly language code, you're always going to have to know exactly which registers a subroutine is going to use. And you're going to have that written somewhere, and you're going to have to potentially look that up. And I wanted to keep the assembly language programming as simple as I possibly could. So I don't really want to do it like that. So let's look at another method. Now the third method which I'm going to show you here is the one which I have decided to adopt. Now what we're going to do is, rather than change the code within the calling function, we will change the code within the actual subroutine. So before we pop any of the values off of the stack or do anything, what we will do is we will store the register values that we need to maintain in dedicated memory locations. So we could say store R0, R1, R2 and the index register into these memory locations R0, R1, R2 and IND temp, and we can just define those down here as our DC commands. Now once we've done that, we can then go ahead and pop the values off onto those registers, knowing that we have a copy of them. Now before we return out of this subroutine, what we can do is we can load all of the values from the memory locations back into those registers. So we will load the R0, 1, 2 and the index register with those values. And of course you have to remember to do that whenever you're returning from the function, and you might be returning from the function from several different places. So in this instance here, we're also returning from the subroutine here, so we would have to do it at this point. Now this has the two advantages. One is we don't need to do anything on the calling function. The calling function will just look exactly the same. So whatever happens within the registers just becomes transparent to us. The subroutine will take care of it. Now, secondly, the subroutine here only places the information into memory that we're actually needing. So it only places register R0, 1 and 2 in the index register into memory. It doesn't put in anything else. So we're going to save a little bit on the overhead for the CPU, and we're also going to make it easy in the top level whenever we write out our assembly language. So this is the method that I am going to use going forward. But before we finish, we'll look at one other method which brings in some other interesting ideas. Now, the last one we're going to look at is actually within the subroutine again, but instead of storing the register values into memory, we could push those register values onto the stack within the subroutine. And before the end of the subroutine, we could pop those values back off. But in order for us to do that here, we would have to adjust the value of the stack. Because the call to the subroutine is going to have the value, for example, the power function, the value a, x, n, and also the return address. Those are going to be pushed onto the stack. And then before we do anything else, we're going to push on the value R0, R1, R2, and also the index register. So the stack pointer is going to be pointing to the index register, which is right about the top of the stack. So if I was just to continue the code as normal, I would be popping off the return address. But I wouldn't get the return address because the return address is further down here. It's 4 positions further down in the stack. It would actually be popping off the index register as opposed to the return address. So I would have to adjust the stack value accordingly. So in this instance here, what I would have to do, because our stack works from the bottom in memory locations and works up the way, so we're subtracting off of the stack each time we add something on, then I would have to add a value of 4 onto the stack pointer, so that whenever we do the pop return address, it actually points to the return address and not to the index, the IND register. So after I've done that, I could work through the code normally, and again at the end, before I could pop anything off, I would have to subtract that value of 4 off of the stack pointer, and then I could pop the values off of the stack into the registers. Now this is a little bit more complex. Now if I was going to do this and do it properly, in effect what we would have here is not only would we have the stack with a stack pointer, we would also have another pointer, and that other pointer would be pointing to the beginning of each of our subroutines. So that instead of me having to add and subtract this value of 4 onto the stack pointer, I could have another pointer which just maintained or held a different value in it relative to that stack pointer. And we could call this the stack frame pointer or just a frame pointer. So I could have another register there and have this frame pointer and set it up as a frame pointer, and then this would then point to different positions on the stack depending on the subroutine, the nested subroutines. But I'm not going to do that because for us here it's overly complicated. We have a simple and elegant method, which was the last method I showed you of just storing the memory location, storing the register values in the memory, and then going to the memory and retrieving them. So we will stick with that third version that I showed you, and we will use that going forward. So thank you for listening. I'll get you on the next video. Goodbye.